Welcome to this lecture. Today we are going to discuss a very important concept in statistics called the random variable. Among them, we are going to discuss a discrete random variable. Consider statistical experiment such that tossing a coin 2 times or 2 coins, you can draw that. Then sample space can be tail, 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 head, head, tail, and head, head. As you know, the classical definition of a probability would be each element is 1/4 of chance. We discussed the probability of a certain event, but this time we are curious too about the number of heads. We'd like to count the number of heads and let x we call this is random variable, is the number of heads. Then the x can have values 0, 1, 2 like this. We have a sample space. In case of a tail, there is no head, therefore the numbers is 0. Head, tail, head is 1. Head is will have a value 2. We call this is the random variable x. Why we are studying this? You can calculate the probability of a random variable, probability of event occurring in sample space. That is useful. But not only that, in a real world application, we are curious about this kind of random variable, counting number of heads. That is the random variable. You may say it is a function from sample space. It's a set to another set 0, 1, 2 to some real number. Function from sample space to a real number, in general we call it random variable. Depending on how many elements in the sample space, we can call them how many values in the random variable, possible values. You can say that this is a discrete random variable. If the possible value is a continuous value, then we can say continuous random variable, which we will discuss in the next section. We can summarize this information, the random variable information, in this manner. We just summarize them 0, 1, 2. Okay. Well, you have possible numbers like this. We combine these two, then probability of x equal 1 represent this kind of event. Therefore, the probability x equal x is 1/4, 1 is 2/4, 2 is 1/4 again. We summarize information about the possible value of x, their probability. We call this is probability distribution function. We denote it usually fx. You may write down in mathematical form. This is the same thing actually. Graphically, this function represents like this. Okay, 1/4, half, another 1/4. You can have 0, 1, 2. This is the random variable and corresponding probability distribution function. In certain cases, we can summarize in this manner. It is useful sometimes. It is nothing but adding, depending on this kind of value, increasing value of this x, we just add cumulated probability. Until 0 is 1/4. It also the 2/4. That means if you add these two, it will become 3/4. Including all, it becomes 1. Here's another representation. In the case we use capital F. In general, we call it, this is cumulative distribution function. Here's a graph for that. Since it is a discrete function, we have a step function like this. It represents mathematically, this function. Here's one simple example. There are 200 families living in a village. They visit hospital. They check some frequency table like this. Then what is the probability distribution? You can define X is a hospital visit. Okay, this value is a possible value of X. Therefore, you can just summarize the random variable, their probability, as just a percent. This is nothing but percent of these numbers. Out of 200 is 37%, 40%, 15%, like that. You can calculate a cumulative distribution function just adding. Okay, this is 0.37 until 1. You add these two numbers, it becomes 0.77. We add this number, it's 0.92, and so on. In case of discrete random variable, since it looks like a function, we need some summary measure. As we did in case of numbers, we are doing same thing. We measure central tendency of a random variable and what would be their dispersion. Graphically, we are talking this. Suppose you have this. Where is the center? It looks like there are three possibilities, 0, 1, 2. Maybe center of gravity is around here. Maybe central tendency of this distribution is 1. What is the measure of dispersion? Some kind of variance. We are talking, considering this is the mean, we calculate some kind of distance from the mean and do it. It is very similar to number cases like this. We call the expectation, the central tendency of a random variable as a mu, and calculating notation is xi multiplied by corresponding probability. The variance x denoted it by sigma square. From each number, subtract mean and square them. We calculate the squared distance as before, and then multiply probability. It is similar except this probability. It's a short formula. We call this is expectation and variance. Rather than showing all kind of graph, simply we just show what is the central tendency, what is there some variance, square the distances, some average, like that. This is the summary of a random variable. We discussed the summary of numbers. Now we are talking the summary measure of the random variable. Here's an example of a previous table. We had 0, 1, 2 possibility. You just multiply corresponding to the corresponding probability like this. Added whole, it becomes expectation as we expected. The central tendency, here we use the shortcut formula, square them, each of them, multiply this number, subtract mu square, it becomes half. Maybe you can calculate standard deviation, it is a square root of this number. What is the interpretation? This is 0.5, therefore, what is the standard deviation? It looks like a 0.7 something. Okay. Go back to this graph. We found the expectation of this random variable is 1. 0.7, the standard deviation imply roughly, plus minus 1 standard deviation. It includes many probabilities. Okay. That's the similar interpretation. Standard deviation, when you consider that from the mean, consider plus minus some kind of wing. It includes many data. in this case, many random variable possible values. Okay, here's some variation of expectation. Suppose you have a random variable and you multiply certain number plus b, what would be their expectation? In case of expectation, it looks like a simple formula. Well, expectation of this number is a times expectation of x plus b. What is the variance? Well, ignore this constant, it becomes like this. What happened? Expectation, let's consider this example. Suppose your midterm score has average 60 points and variance is 100. And professor is thinking, giving some kind of some cover. How about this? We want to add 20 points to each student score. What would be expectation and variance? Expectation means the same thing as mean. If you add a whole number, if there is a distribution, adding is just to shift everything to the right-hand side, 20 points. Okay? Therefore, expectation is increasing, but variance is not changing. That's a simple answer. How about if you multiply 1.4? You have original data. Okay? If you multiply 1.4, then the data will become more spread. Therefore, expectation definitely some change, the variance become change. How much? The first question is simple. Expectation of x plus 20 is nothing but the original average plus 20. Variance stays same. But if you multiply 1.4 of the random variable, well, you just expectation is multiplication of 1.4. But in case of variance, it becomes much spread of this amount. Okay? If you change a random variable in this manner, here's the formula. Okay? Well, this one look like a natural 1.2 original expectation plus 10. But in case of variance, well, this constant doesn't reflect anything. Okay? It's just a shifting, no variance change. Here's one great application. You will use these things a lot. Suppose you have a random variable x, their expectation is mu, standard deviation is sigma. Well, what would be this random variable? From x minus mu, suppose if you subtract mu, what would happen? Then mean becomes 0, right? But by this transformation, the variance will not be changed. Right? Just to shift to the maybe left-hand side. But if you divide by sigma, after you moving to 0, divide by sigma will create, variance of z imply 1 over sigma square will come out. Therefore, variance become 1. We call this is standardized random variable. We'll use this a lot. Okay, next class we are going to discuss some more specific discrete